The energy valve has many integrated functions to perform energy optimization and make HVAC systems more efficient. My name is Joerg and I am the product manager for the energy valve at Belimo. The heat pump or chiller produces thermal energy with the help of electrical energy and primary energy. Here in this system, in order to improve energy efficiency, the energy valve can be installed in such a system. The valve contributes to this improvement through a better leakage rate, pressure-independent flow control, and delta T management. With the leakage rate and PI function, we reduce the share of thermal energy, and with the delta T management, we reduce the electrical energy. Where does the energy valve help? The energy valve helps in 3 places in a building. Reduction of the energy flow through a better leakage rate. With the hydraulic pressure independence, the pump performance can be reduced by reducing the differential pressure at the pump. And increasing the differential temperature in a condensing boiler improves efficiency. Therefore, I would like to briefly address these 3 points below. Improvement of energy efficiency through a better leakage rate. If a valve leaks, when closed, energy is transported from the generator to the heat exchanger. This amount of energy is delivered to the heat exchanger. It can be assumed that this energy output is not required if there is no flow or power requirement from the valve. This amount of energy, therefore, can be regarded as a loss. As we have already learned about energy efficiency from another SESIM module, this energy loss of a globe valve can be calculated, and it can be quite high. In this example, we have a leakage rate of this globe valve of 10.1 liters per hour, which leads to an energy quantity at zero load every year of 710 kilowatt hours. Therefore, in comparison to a characterized control valve from Belimo, we do not have consumer activation at zero load, no unnecessary energy loss to the consumer, and therefore reduced energy consumption. Improvement of energy efficiency through pressure independence. In 2016, a study was carried out in Switzerland with the aim of demonstrating the potential for improving energy efficiency in Switzerland. Heating system, hot water system, and HVAC technology were analyzed. The basic question of this study was, where and how can energy efficiency be improved in building services in Switzerland? In order to optimize existing heating systems, hydronic balancing is listed as an important measure in this study. With the hydronic balancing, which is carried out not only static but also dynamic at partial load by the pressure-independent control valves, energy saving and improved energy efficiency of 10% can be achieved. That means with our electronic pressure-independent valve we can save 10% of energy by having a dynamic hydraulic balancing. Improvement of energy efficiency through delta T management. A condensing boiler is a boiler for hot water heating systems, which almost completely uses the energy content of the fuel used. In condensing boilers, the gas in this first heat exchanger is cooled as much down as possible at the condensation heat of the water vapor contained in the gas. In the second heat exchanger, the water is reheated by combustion. The calorific value effect is achieved by low system temperatures. Due to the low return temperature, the gas are cooled and condensed. The lower the return temperature is, the better the efficiency, because I have more condensation heat in the gas. So therefore, the energy valve can ensure that this efficiency is guaranteed for condensing boilers. We can see from a practical example what such an increase in energy efficiency really means. Here we can see the data of an installed energy valve with a condensing boiler. The installation data show an output of 7.9 kilowatt, which is achieved with a flow rate of 17 liters per minute and a differential temperature of 6.6 Kelvin. These values can be massively improved with the delta T manager, as we can see here on the next slide. Now I have the same power output, and with an installed and active delta T manager, I have here the energy valve a much lower flow rate of 8.7 liters per minute and a much higher delta T of 12.6 Kelvin. So now I see with my condensing boiler the differential temperature and the return temperature is lower, so therefore I have more efficiency on the condensing boiler and I need less energy on the pump side because I have a lower flow rate. We have demonstrated the improvement of energy efficiency in a practical project in UK. The building is a very big library with 120 air handling units and old globe valves. These globe valves, these 120 globe valves, were replaced by 120 energy valve. And we calculated the energy saving we did with the energy valves. Thanks to the installation of the energy valve, annual savings in thermal energy can be achieved thanks to a better leakage rate and the pressure-independent flow control. These total savings were about 15% every year in thermal energy. The thermal energy consumption is reduced by a total of 667,000 kilowatt hours, thanks to the installation of the energy valve. In summary, it can be said that with the Belimo energy valve, you can achieve a triple improvement in energy efficiency with the same comfort. Only with this one valve, it is possible to have an influence at 3 points in a building. A better leakage rate reduces the energy flow, reducing the differential pressure leads to less pump power, and we achieve higher efficiency at the boiler through delta T management. Thank you for your attention.